Hello everyone and welcome back. Sorry about that. Ran out of time in that last segment. So where we left off was we had broken up our chlorine into two atoms, and we have the bond energy that was needed to do that for 1 mole of chlorine. And so the next thing we want to do is make sure that we have this as an anion. So we want to make this into an ionic gas as well. So we have our magnesium, our gaseous magnesium ion that we want. Now we need to make this into an ion. So what's the equation for that? Well, it's an affinity, electron affinity. So we're giving an electron to chlorine. So we just need to write the equation that represents that. So in this case, we're going to have one chlorine gas, and we're going to add one electron. We're going to add an electron to it, and that's going to make it chlorine minus gas. And then that's it. So that's the equation for electron affinity. We're adding an electron to an element in the gaseous state, and we get a gaseous ion. Okay, so we have our ions. We have our gaseous ions here, our chlorine and our magnesium. So the only thing we need left is the equation that represents the lattice energy. So what is, again, the definition of lattice energy? It's where you take your gaseous ions and we bring them together into a solid. So let's write the equation for that. So we're going to take our gaseous ions. We have magnesium 2 plus gas plus chlorine gas. So it's chlorine minus gas. Those two together are going to make solid magnesium chloride. So that's the equation for the lattice energy. So the process, whatever the energy of this process is going to be the lattice energy. So delta H is equal to, we should say delta H lattice is equal to, we don't know. And then before we forget, we should write down the electron affinity for chlorine for this process here. And that process is, if I look it up really quick, oh, excuse me, that's going to be a negative 349. So that's going to be, and we'll write electron affinity is equal to negative 349 kilojoules per mole. So we have everything we need. We got all of our equations, and so we're done. Now all we need to do is use Hess's law to figure everything out. So remember, everything here should add up to this equation here. This is our equation for the formation of magnesium chloride from their standard elements in their standard states. So let's make sure we have this. So we should have, everything should cancel out except for magnesium solid and chlorine gas and magnesium chloride solid. So everything else should cancel out. So we need to make sure that that happens. Okay, so you'll notice, okay, so everything, anything that's on the product and the reactants is going to cancel out. So I have one magnesium gas, one magnesium gas. So that's going to cancel out. Okay. We have magnesium plus gas, and we have magnesium plus gas. So that's going to cancel out. Also, we have, let's see, we're going to have to, let's see, where are we? Magnesium 2 plus, so we've got this. So this is good. So we have our magnesium 2 plus there, and we got magnesium 2 plus here. So this is going to cancel out. So that's gone. And the next thing is, here we have our solid magnesium salt. We got our chlorine gas. We got that. That's going to be 2 chlorine. We have 2 chlorine here, but we only have one chlorine here. So what we need, oh, and we need to balance this equation here. We forgot to balance this equation. So this is going to be 2. So we have 2 chloride ions here to get the 2 chlorine atoms there, 2 chloride ions there. So okay, so that's balanced. So we have 2 chlorine atoms here, so we're going to need 2 chlorine atoms here. So we're going to have to double this, right? So if we double this, remember we need to double this as well, okay? So we're going to double this equation. So everything gets multiplied by 2, okay? So this becomes 2. So we got 2 electrons there, and this becomes 2. We got 2 chloride ions there. Now these 2 chloride ions here are going to cancel out with these 2 chloride gas ions here. So that's going to cancel out. Notice we have 2 electrons here. That's going to cancel out with these 2 here. So that cancels out. What else? So we have our magnesium. That's good. And we have, what else? We have 2 chlorine atoms here. We have 2 chlorine atoms here. That's going to cancel out. So that's good. We have chlorine gas, and we have chlorine gas. So that's good. Okay. So everything cancels out except for the things we want. So here we have magnesium, chlorine gas, and the solid magnesium chloride salt. So everything cancels out and gives us this. So since that's the case, then we can use, we can continue with Hess's law and say that these 5 or 6, 1, 2, 3, 4, 5, 6, these 6 are going to equal this one here. So we can set up the equation to solve for the missing part. So we know all of these. The only thing we're missing is the lattice energy. So we could just set up the equation and solve for the missing part. So let's do that. Let me pause for a second. Okay, so what I did was that I erased the board to make room. So this is all I need at this point. So now I'm going to set these up equal to that. So I have the heat of sublimation. So I'm going to have heat of sublimation plus IE1 plus IE2 plus bond energy. And that's going to be, and then 2 times the electron affinity. So again, this is going to be times 2, plus the lattice energy. So delta H, I'm going to say lat. And all of this is equal to delta H, the standard delta H formation. So now all I need to do is plug in all these values, and then what you do is solve for the missing part. So everything I have is given. So then if I rearrange this, what's going to happen is I'm going to have, here's my lattice energy. So what if I rearrange this, then I get delta H of the lattice energy is going to be equal to delta H standard formation minus the rest of them. So minus, let's see, minus the delta H for sublimation sub plus IE1 plus IE2 plus bond energy plus 2 times the electron affinity plus, oops, do I need anything else? I think that's it. So let me write that in here. 2 times the electron affinity. So I got 1, 2, 3, 4, 5, 6, 7. Okay. So then all I need to do is plug in the values for here. So this is equal to, and then I have this. So I have negative 641 kilojoules per mole minus, and then I have these. So it's going to be plus 147.1 kilojoules per mole plus 738 kilojoules per mole plus 1450 kilojoules per mole plus, and then that's going to be 243 kilojoules per mole, and then this is multiplied by, and then plus 2 times negative 349 kilojoules per mole. Okay. And that's it. So all of this is equal to the lattice energy. So all we need to do is just calculate. And so the answer is, we get negative 2,521.1, and that's kilojoules per mole. And so as you can see, this is highly negative, so very strong lattice energy for this, most likely due to the fact that you have a positive 2 for your magnesium. So I hope this was helpful. So as you can see, the steps are fairly straightforward. It's just you got to remember how to write the equation for each step in the Born-Haber process. So and then once you got all the steps, you're going to add them together using Hess's law, balancing, making sure everything cancels out to get you the equation, which is the standard formation equation for that particular salt. So I hope this was helpful. If you like this video, share this video, hit the subscribe button, make sure you subscribe to the channel, and make a comment in the comment section and let me know what you think, and any questions you have that you would like me to answer. Thanks for joining me, and I'll see you next time.